And the last reason why I do this talk is because I need to find a reason to justify over 6,000 hours played into this type of games. This is also a reason to tell my wife and my mother, see, this is why I play. So I have an excuse now.
I think we want maybe to hear more about how can we learn Ruby or understand more about Ruby, but also using it in a kind of game environment. And I think that's also a very fun way to dig into technology while trying to use it for something that is fun, like games. So a round of applause for Victor.
Hi everyone. Thank you very much for the introduction, and I just want to thank Adrian as well, because I think in the post that he mentioned how big Counter-Strike was in Romania, especially a few years ago, and that's exactly why I decided to do this talk. And that's exactly why I took the liberty to copy some of the design that Friendly had in the past few years, even though you didn't necessarily ask us to, but I really wanted to highlight this design because we really love it, and great job doing it. So, hi, my name is Victor. I'm the head of web development at Wolfpack, and although I do web day to day, after, let's say, 5 p.m., I love taking a chill pill, let's say, in Counter-Strike. So I love that Carmen talked a little bit about mistakes and learning. I never learned to put this game down, although I should. But what I want to talk today is some cool stuff that's implemented behind these servers, networking especially, and what can we learn considering we build these kind of apps day to day. And although they seem quite different, they aren't that different. So a little bit more into why am I talking about this. And the main reason is I don't think people realize how huge gaming is right now. For example, specifically Counter-Strike had almost 2 million concurrent players multiple times this year. I checked yesterday, preparing for the talk, they had over 1.4 in a random Wednesday. And let's not consider different time zones. There's a lot of people in the Americas playing, in Asia playing, and also Europe. So I was basically checking when a lot of people worked or slept. Besides this, specifically in Romania, one of the biggest event organizers for these type of events is a Romanian society. One of the best Counter-Strike players is Romanian. We had in 2021, right here in Bucharest, competition with over $40 million prize pool, which is huge. And in my hometown in Cluj, we have an yearly event with over $1 million as a prize pool. And also, like I mentioned, and why I mentioned Adrian's post, we had the best servers. So in CS 1.6, if someone wanted to play on community servers, they were most probably playing on Romanian servers because they were always the best. And one fun fact, OpenAI actually received investment from Microsoft because they created an AI that played 1v1 against pros. They won every single game, and that's what took Microsoft's attention. And now we have this great tool that we talk about 2 days at conferences. And the last reason why I do this talk is because I need to find a reason to justify over 6,000 hours played into this type of games. This is also a reason to tell my wife and my mother, see, this is why I play. So I have an excuse now. But what I think is the base of this talk is basically that games are software. For me personally, every time I download an app or every time I reach a website, I start thinking about how is it implemented? How would I implement this? I'm not sure if we do the same with games. At least I didn't until maybe 1 year ago. Because the truth is that especially multiplayer games are extremely similar to web applications, especially backends and servers. They need to handle constant updates. They behave like live services. They need to scale. You never know when you have 100,000 players or 2 million players. Besides this, their finances are very important. They make their money by user retention, because once you bought the game, or even if the game is free, they basically make money by selling you other stuff inside the game. And I think there's a lot of things that us as developers, we can learn for this type of software, even if we aren't actually game developers. So before I start actually going and deep diving inside Counter-Strike, I made a very general rudimentary graph that highlights what type of lag we can expect from pressing a key on the keyboard to actually seeing the result on our screen. This is especially for multiplayer games. Of course, there's input lag because whenever I press a key, the hardware has a bit of lag. Then there's the network transmission because, of course, sending data from my PC to the server takes some time. Then the server needs to wait a bit for packets. It needs to process them, then send them back, and then the UI needs to render. So I think that even in the best case scenario, we can expect a few milliseconds of delay. And this is even if I run everything locally. Now, imagine if we have actual servers that's thousands of kilometers away. There's people playing from all around the world. And if you want to play this competitively, there's normal idea that the developers want to make this as smooth as possible. So let's see what they're trying to do in order to make this as smooth as possible. I'm basically going to talk about one game that's split into two engines. So this is basically Counter-Strike. The first one was updated and maintained from 2012 to 2023. This is Counter-Strike Global Offensive, and their servers handled network packages a bit different to what you might expect. There were basically 64 and 128 tick servers. Data was sent 64 times per second or 128 times per second. Official servers were only 64 times per second, which basically meant that every action required at most 15.6 milliseconds to send, but sometimes it was less. The idea is that in case I did something between these type of ticks, then it would only be processed on the next tick. And that's what I wanted to highlight in the video here, is that even though I should have shot someone, my enemy, inside the video because on my screen everything was accurate, the server was causing me to miss. And in professional Counter-Strike, this was a huge issue. Then, of course, there were the third-party servers because people realized we can do better, and they basically made this type of refresh rate to be 2 times as fast. And this solved some issues, but the underlying technology was still deprecated. I think there's a similar implementation in Sidekick to this type of tick system. The most easy analogy would be their polar and their heartbeat, which basically means that the Sidekick process every 5 seconds sends to the backend process a heartbeat to say, yeah, I'm still alive, I'm still working, don't worry about it. But there's an even more interesting thing implemented in Sidekick, which is basically the scheduler thread actually taking jobs. Because when a new job is enqueued, it doesn't go straight into Redis, because that would basically mean that from time to time, it might overflow the process. So what they have implemented is actually a random wait between 10 and 15 seconds. It's always at least 10 seconds, and then they add a random between 0 and 5 seconds to do that. And this basically means that you can't for sure say when an action will happen, just like I mentioned with Counter-Strike. It's basically always happening in the next tick or in the next, let's say, random second. Now, like I mentioned, they updated this. So they did a port from the game engine source 1 to the game engine source 2. And this actually meant new graphics, the game working a bit smoother. Actually, it made it be a more modern game, because although there were a lot of money pumped into this game, it was quite an old engine. So in 2023, they did this update, and they implemented something new on the servers as well. It's something they call the subtick engine. In the previous example, I mentioned a very simple action where I'm shooting someone and it's processed on the last tick. But in an actual competitive game with at least 10 people in the server, there's a lot more actions happening. And the main issue here was that although they were sent with a delay, which is obviously already an issue, they didn't even know the order of the actions that happened. And the server had to do, I don't know, a scoring algorithm just to know, okay, in which order are we processing? So if, for example, me and you will shoot at the exact same time, we were basically at the mercy of the server to decide who shot first. So what they did was actually implementing this subtick system where with each action, they also send a timestamp. And this would basically allow them to send the data as rarely as before, but now they could calculate everything extremely accurately because they knew the exact order of actions that happened. This sounds very good in theory, but the truth is it was disastrous. The thing that happened is that the things that were rendered on the screen weren't the things that were actually calculated on the server. Because the UI can't really wait for the server to calculate everything. The UI needs to render, and the game engine needs to process those frames just so I don't wait 15 milliseconds. Imagine my screen just freezing every 15 milliseconds. They had to split what happens on the UI and what's calculated on my PC and what's calculated on the server. This caused a lot of bugs. And like you can see in the videos, there's a lot of people dying in places where they should feel safe. And this is just because rendering on the game and rendering on the servers were very different. And this caused a lot of outrage. And like I mentioned in the previous slides, game developers have an especially tricky challenge because they have to please both casual and professional players. And with these changes, it looked like it didn't please anyone. Besides this, they tried to do a lot of fixes. So 2 years have passed. I have actually did a similar talk before, and I wrote a very weird Reddit post about how about we do optimistic rendering in games. And it looks like 2 months later after I wrote that post, they tried implementing it, and it was a huge disaster. The thing is that in games, if you see an animation of someone dying, but they come back and then they kill you, it's extremely terrifying. And the game is actually made in such a way that you dying is very punishing. And the animations, like you can see, are trying to make you feel in a certain way that you want to go back the next round and do it again. And this is pretty good for user retention, but this is pretty bad when it doesn't work. Besides this predictive damage part, they also worked and tweaked a little bit on the movements. And this was very weird as well, because when I press to jump, the animation, like I mentioned, needs to be handled on the UI, but the actual place where I land is handled on the server. So imagine me doing the same action time and time again and landing in a different spot every time. And there were actually people in professional teams losing rounds and potentially millions of dollars because of this bug. So what went wrong? Like I mentioned, the main thing that went wrong was what can we render on the UI, what actually is an animation, and what's an action registration. So like in the video here, you can see that even though I shoot in the correct frame, if I have a lot of time to move by then, the shot will still register. But that's a completely unnatural visual representation of it. And this is a server that we slow down a lot just to showcase this. The thing is that we have to decide what we prefer. Is it server accuracy? Is it actually objectively representing everything in the correct way? Or is it visual accuracy, where my feedback, my visual feedback is actually the correct one? And like I mentioned, it's very frustrating to feel like you die when you have cover, because this is how the game is made. Now, as developers, we have to think a bit about why they did this. So, like I mentioned, the pros are the accuracy is a lot better. But besides this, their infrastructure costs went down a lot, because now they can always use the 64-tick servers. They actually implemented this and hard-coded it into the code. So even third-party servers can't make it faster, because, of course, you have to process things 2 times as slower. But the con for this is that although you can process things slower, you have a bit more to process. Let's say in the very unlikely example that 1 million actions happen in 15.6 milliseconds, then my server has to order by timestamp 1 million actions, which is a lot more processing that I have to do. And of course, like I mentioned, it's very difficult to decide what is actually calculated on server and not. This is something that they tweaked a lot. Now the movement is calculated on the server as well, and the animation is predicted in a different way. But it still feels a bit unnatural. What can we learn from this? And I'm talking about this especially from a web developer's perspective, because this is what I do from day to day. On the front-end side, we can use a lot of optimistic rendering. Now, this is something that a lot of sites already use. This is something that I'm sure some of you already use. But it's a cool thing to think about it for every action that we think has a high success rate. For example, in GitHub, I can see that the animation for starring a repo is considered as a success even before the network response comes as successful. And this is something that we can implement only, like I mentioned, on high success rate actions, because I wouldn't really like this on merging a repository, but having conflicts after that, because that would obviously mean a lot of issues. On the other hand, it also teach me to think a bit more about users that might have a little bit of latency. Their network might be slow. So right now, I'm trying to test a little bit more with the Chrome dev tools or with other dev tools just to see how people with very slow internet would see my app. This helps me think a bit more, again, about optimistic rendering, but also about caching for them. Because before, I could have just tested it on my usual workflow and see no issue, but my users would probably not have the same user experience. And talking about user experience, the second example, especially on the backend side, I was thinking about chats. But this is not only about chat, this is a lot of other features that we can use. And I'm sure this is nothing new, but for specific features, an event-driven architecture is a lot better than just pinging for answers or waiting for the response or so on. We have a lot of tools for the event-driven architectures already, but the thing is that it's good to think about them from the start, so we don't have to refactor them later. And it also made me think a bit about improved monitoring. Because for me, for example, using a lot of monitoring tools and the APMs, it might tell me that a specific query only took a few milliseconds, and that's very fine. But what if I put timestamps on everything and actually look on the timestamps from OpenTelemetry logs to actually see that the database log took 200 milliseconds, although the query took 5 milliseconds? For example, New Relic won't show me that, but if I actually look into the logs based on the timestamps, just like a subtick system would, it would show me that the users would actually have a bad user experience. I also had a crazy idea yesterday, and I was thinking this is not something that's implemented right now, but what if we can do this type of subtick system on database logs? What would have to happen for me to be worth it to process batch conflicting queries instead of taking them one by one? So what happens is, yeah, the database can handle multiple queries at the same time, but in case they are conflicting, basically taking one by one, putting a lock on the database and moving on to the next. If there is a world where it's worth it for me and the processing on the database would take less than transferring that data multiple times for each type of transaction, then it would be worth to handle them as a batch and just wait 15.6 milliseconds, for example, taking 5 of them, processing them, and then moving on to the next. Because basically, I won't have that latency 5 times. And the last thing that I want to mention is that other games have this as well. There's more to Counter-Strike as well. Maybe at other conferences, I'm going to talk about how they are trying to fix the problem of hackers with AI, and it's not working at all. I wanted to mention that there are other games that have the same system, but they do it a lot worse. For example, RuneScape has a tick system of 0.6 seconds, and I don't think anyone has a reaction of 15 milliseconds, but of 600, I'm sure we all do. And the idea is that people are actually implementing mods just so they can cheat in the game by doing things that are processed twice, or just doing actions before the next tick is actually happening. And there's also another thing that's cool in Street Fighter. It's called rollback netcode, which basically means trying to predict visually what the animation would look like. Because, for example, 2 opponents are having very different latencies. This delay is just a prediction, just so visually we don't see that delay. And in case this goes wrong, it basically a laggy rollback where we get back to the previous animation, and it's horrible to see, but it works pretty well overall. So that was it. Thank you for listening.
Thank you very much. Thank you.